Hi everybody, this is more of an achievement unlocked than a how to do it video, but based on some really good results gotten by people who I respect online who say, "Anneal your brass after every shot, before every reloading," I said, well, let's try that. And so I made an induction annealer to do it, which is running now. The grain of wheat balls over here tell me there's AC, because if the thing doesn't oscillate, it burns itself up pretty quick. Hasn't been a problem since I found the right coil dimensions, which I found online. Now, I've noticed one thing, which I sort of made this video to say, which hasn't been in any other video that I've seen, and that's different brass, like different headstamps, requires a different length of time at this fixed power output to hit temperature. I'm using Tempolac, and I paint up the downside of the brass with 750 and 650 to make sure I'm not heating up the wrong part of things. And interestingly enough, the thinner brass, or I assume it's thinner because it weighs less, takes longer. Now, this may be why our Kiwi friends over at AMP, Annealing Made Perfect, went so far out and made something that cost $1,400. I have nowhere near that in this. 48 volt, 20 amp power supply is most of the cost. This is an inexpensive self-oscillating induction heater from China. Did the little overpriced, but $10 solenoid. This is an Arduino with some shields I had laying around that I was never going to use because the new stuff is so much better. And a little cheapo cooling pump for liquid cooling for computers. This big coil over here is not an inductor anymore. This is the inductor that came with the thing, but it makes too large a field and not concentrated enough to anneal brass. So I'm using it as a radiator. And there's a little fan under this piece of wood that's blowing air up through the thing and out through the coils to keep from boiling the water. And now I see why the amp box has all those fans on it, because out of the kilowatt or so this is thrown out, a whole lot of it becomes heat that isn't in the brass. If you see a little smoke coming out of here, that's despite wet tumbling and then dry tumbling these before doing this, and decapping them so they get really, really clean. I'm thinking that being shiny on the inside in terms of infrared reflectivity probably affects combustion of the powder, or the rate of increase of induction of the powder. And that might be more of it than the neck tension that everybody obsesses about, but you never know. Hyper-accurate shooting, and this rifle I'm working on will generally put them all in one hole. I'm just working on the size of that hole. Everything counts. It's all about consistency. So I thought I'd try this, because you get brass mixed up. This has been shot 3 times, it's been shot 5 times, and so on. It seems like if it's all the same hardness and so on, you're good. And this is all mixed head stamps because I've used different loads. That's one way I tell them apart. But before this goes anywhere back into loads, I'll separate it and sort it by head stamp and by weight. But this thing works pretty nice. It's not as automated as some, and maybe probably not as cheap as one you could make with a little motor and a propane torch, but it was fun. I learned some things about induction heating, which always fascinated me, but I never got around to actually doing it. And now all this stuff is dirt cheap, so why not? And we've just done a lot of brass. So that's really all I had to say. People bang on me in the comments about exactly what the part numbers are. If I can find them, I'll post them up. Pretty much all this junk came off of Amazon except the copper tubing. So what can I say? This is a headlight relay. It's pretty conventional stuff. It's all straightforward. So have a good one, and thanks for watching.